take out 2,500s worth of shims. I want to get this down to the point where it is no clearance, but no drag. You don't want to take out 30 because then you go on the other side where you're pushing the bearings into the race. We have a, I guess, an 87 vintage gearbox that belongs to Mr. West here. And then we have a probably 1990 vintage gearbox over here. And I think pull apart both of them because there's some real essential differences. Both of these have got the newer, larger inner drivers on them. And again, one of the things you'll look for in terms of you're just going through scrap piles or trying to sort out what gearbox you got is just even the number of ribs on the drivers here. Find 2 versus 3 is one, rough indicator, but the main difference is the diameter and the width of the bearings that sit here in the trunnions. And we'll start passing things around, but as mentioned earlier here, if you get into Larry's box on the passenger side here, we've got some horrendous pockets where, again, point of contact between the axle and the driver. Okay, as far as some external differences on these, just as we go along, you'll find that rear covers on these are different, which means that we have I'll start pulling tools out in a bit. You find that on both of these, the selector shaft, the little stub that sticks out here, has got 2 holes. If you get a real early, not real early, but at this point, I guess we are talking real early. You go back far enough and you find a single hole. The one towards the back here is for your paper pin, of course, holding the coupling on, and the forward one is for an alignment tool. It's a means of locking the gearbox in gear so you know that the gearbox is precisely where it wants to be while you're back there positioning the shift lever and making sure that the pinch hold on the coupling here is tightened down in the right place. Okay, went through that whole song and dance because if you get looking, there are 2 different rear covers on these. Rear cover on this fellow is pretty much contoured to face or to follow the shape of the pinion, whereas this one is a much boxier design. You'll see when we get that off that there's actually a filter built in here. We are in a splash method. We are, of course, ring gears picking up oil, and we are splash feeding the oil down against the rear cover down through the filter and trapping, hopefully catching metal particles before it gets a chance to go through the mill again. Another difference is the side covers. This fellow's stamped. This one is heavy cast. This is certainly if you're poking through scrap yards and looking for gearboxes, you would hope to find one with these characteristics: the boxy rear cover, the heavy side cover. Big difference here is beginning in '89, we upgraded. You find the main case itself is different as well because we upgraded the pinion bearings, so different main case. A lot of detail changes inside. Went to some chrome plating on the selector mechanism, trying to, again, we always fought, the old 4-speeds when they got broken and shifted like a dream. The 5-speed, of course, in classic Swedish fashion, it's both their strength and their weakness. Whereas if you go to General Motors, you can spend an entire week just finding the 100 people you need to talk to get one answer. And you go to Sweden and you find out there's one guy that does everything pretty much, and which makes it real nice from a standpoint of communicating. The other thing you find is they don't have a whole lot of money, so that they which got into very clean, elegant engineering, but it also meant that they tended to live with designs sometimes a lot longer than they needed to. So when the need for a 5-speed came around, it wasn't like, oh, let's go back to the drawing boards and do what the things. You can guarantee if you talk to the engineers, each and every one of them probably knew exactly what, given their druthers, they would have done. But it's so make it work. So what we did here was, there's essentially no real difference between, say, one of these main cases. You could build one of these in a 4-speed if you wanted to. Well, it'd be hard to do this one, but maybe you could. All all they really did when they turned this into a 5-speed is we modified the front housing and extended the cluster gear out and stuck on another gear. And as a result, it tightened up the, the shift linkage there. And you didn't have quite as much clearance as you did initially, and the shift quality suffered a bit. They got some of that back on the later one here, but again, chrome plating and a few other internal changes. Okay, so having said that, I'll let you guys, I know a bunch of you have been doing this. Well, let's strip the covers off. There is I don't like air particularly, but there is a battery-powered rattle wrench back there. And let's just pull the covers off of this. This guy, Larry's drain, he's likely to seep a bit, so I'll go with hand. Anybody that has any ambition here? Well, some of you have been doing these. So, yeah, come on. Yeah, good.
My box.
Easy.
Yeah.
So bring that over.
Is your battery over there, or?
That's a spare battery. There's one on charge and one. Actually, for tear down, there's nothing wrong with air. It's just I won't come back together with air.
Yeah.
So,
What year is that box? This one's out of an 87.
yeah, what's that doing?
Exactly what I'm going to be looking for.
Honestly, I don't know. I bought this from somebody, and they told me it worked in the car it came out of.
Guys,
Wait till I guess.
got it right behind you.
Okay.
We're going to strip down this one as well. There's some here. You're
You have hands for the bolts or something? So we.
now. Let me coffee cups.
Right.
Change the pace. Last thing I did with these was overhaul the carburetor. Okay, we'll leave the side covers on for the moment here. We don't want to change the preload, but let's get the we'll take the drivers, but we'll do everything along here.
Now I see why those other brackets are so much better. Go in.
Yeah, you're most of them.
There's a lot of that.
I think what I've got coming out of this mostly is water right now. So I hit with pressure washer, and I stick to the.
These are the pinch depth gauges you see in the manual there, and essentially you need a flat gauge block to indicate its length. And then these radiuses here, these arcs, conform to the idea of the side covers here. This is the fixed point. You actually can see in effect a lathe center here on either end of the tool that would correspond to the center line on the ring gear, and then the gauge block would represent the face of a zero spec pinion. Then it becomes a matter of how you move it in there.
The side cover.
Now, if you got a working with these, the trick is to set. They've got a lot of stroke on either side. There's nothing worse than spending a long time shimming pinion and realizing that you had the dial indicator at the absolute end of its travel, so you actually have, you weren't touching the pinion. Something else you need to do is all of these dial indicators track both hundredths of a millimeter and a small dial which tracks one complete revolution. And you need to keep an eye on what the small dial is doing, so you don't end up with, again, 1, 2 complete revolutions off. Pretty hard to do because usually the things will repeat fairly well. But if you're building something up out of a basket case where somebody's just thrown away all the shims, so it is conceivable that you can get a full millimeter off.
Want the chain drive cover off?
Chain drive cover as well.
You have a magnet for the ball?
Good. Okay. The one in the corner behind. Yes. Yeah, you're right. Okay. The detent spring. You got the spring out?
The spring, yeah, the spring
Springs in. Okay.
should be underneath the.
Okay. One of the many bits of Saab lore here is again, you'll occasionally go round and round with a gearbox that will jump out of gear. And this spring has been upgraded over the years. One of the early SIs, early bulletins, involved your first line of defense there was whip off the side cover in the car and take a short screw with a head that was just about the same as the OD of the spring, and you'd shove the screw in the end, and you'd increase spring tension there. Sometimes that would be all it would take to keep the thing from shaking itself into neutral and jumping out of gear. Then later on, they went to a stiffer spring. Something else along the same line, that spring is bearing down on this ball, which is going into your detent mechanism on the selector rod. Probably any gearbox that had that problem have been sorted out, but occasionally would run into a box where you'll find they would not have bored the hole for the ball quite deep enough, and the ball would bottom out in the case but not be bottoming out in the groove in the selector rod. And again, you get a very feeble interlock type of, and it would not, they'd pop out of gear. Okay, so we can pull off the front cover. Okay, and then we're getting into, let's see how we're a little bit tight.
On a very. It's the recommended way of pulling with it.
Whack it. It's a little smoother, but I don't think so. Okay, what we're getting into, I don't want to hit you right there, Larry, so let's, okay, what we're dealing with on, if you look at the two gearboxes right now, okay, this is the latest generation box, and we kind of reverted back to some of the earlier ones where if you look at the lower end of the input shaft on this box, we are looking at a nut holding the sprocket on. Okay, if you look at this fella here, we've got a support bearing. That's characteristic of the early days of the 16-valve turbos, where what they were concerned about was enough power so that you're going to do this, that shaft. We're looking at, essentially, if we get inside here, pinion shaft running essentially here to here, and then we have a short coupling shaft attached to the bottom sprocket, which is taking power back to the pinion shaft. And that's supported with two tapered roller bearings, which are very close together. You don't have a lot of, in effect, leverage there or support, so they were worried about the shaft tilting. So the early ones, they went to a forward bearing there, and then they went to, they've all have had a collecting device here. You'll find you have an oil cup, which is plugged right into the center of the shaft, and then is going on down, feeding the oil back through the center of the input shaft back into the pinion. They finally decided, oh, what the heck? I guess it wasn't much of a problem, so they reverted to this style. Okay. Yeah.
But it's the same input shaft?
Well, the difference in the input shaft, it's again, if you get into the parts book there, and quite honestly, hate to admit it, but it's been long enough, so the stuff is starting to get a little hazy here. What you had to be careful about, one of the things we noted in there is, well, first of all, we had to extend the shaft here in order to put a bearing on it. Okay. And they also had to modify the front cover. And you get into front covers, you're also looking at a difference from front covers for hydraulic mounts and conventional mounts. So you get the different styles of mounting pads there. Okay, so in addition to having extended shafts for bearing and shafts that weren't extended, you'll find that we also had a difference in effect, the width or the thickness of the carrier that has those two tapered roller bearings. So you have some subtle differences, but there are differences in the overall length of the shaft itself with regard to the area where the bearings are riding as well. Okay, it's been a while. It seems to me this bearing usually just slides off of the shaft here, so we may have to get in and gently help it along. In both cases here, if you get looking, as far as one of the things you need to be on the lookout for as you're coming apart here is the chain wear. And Larry's, which has got Lord knows how much mileage is not significantly different from here. Spec given in the book was you did not want to have, I think, less than 10 millimeters. That is a tremendous amount of wear. This is normally in the ballpark of what you'll see. I've only run into a few personally that were badly worn. They will make quite a racket when they get if you get to the point where your rubbing blocks have come out significantly, you'll get a fair bit of noise.
Where do you look for the wear?
Okay, you are looking for clearance here. Just how much clearance do we have between here and here?
You're talking between the chain and the housing.
Between the chain and the housing, yeah. Although,
And 10 millimeters is,
look at that was somebody can. I'm doing that from memory for a decade ago, but I think that was the spec I put in there.
so it should be less on a good box?
Well, the closer you are in, this is about standard. Okay, it's when you're out to there that you got trouble when they're well out.
But that will indicate wear on the chain. Or
It'll indicate chain stretch.
What about grooves in the?
Light grooves in the rubbing block, I'm not going to get if they're still unless they're rock hard. I'm not going to get too paranoid. Again, anybody here that has got practical experience on any of this stuff, chip in. There's no pull the knowledge here certainly. Haven't seen a lot of problems with the rubbing blocks. Rarely do I get a lot of chain stretch. If it's something you need to be on the lookout for. Probably more importantly is the fact that, again, at this point, these all got a lot of miles, and you are getting chain stretch, and there is a little movement, so you find that the wear pattern, inner to outer, is going to be a little bit different. Mm-hmm. So it's worthwhile, just as with anything else, just try to keep things where they are. If it's a muff that was pointing this way, originally put it back the same way. If if this was the outer chain before, put it back that way. So usually just the clearance here is is sufficient. These all have equal amount of tension by feel. It's conceivable that somebody else could have gotten in and swapped old and new. Danger with having mixed and matched there is you get one guy that's carrying all the load and somebody else that's just along for the ride. So you want to see if you have a fairly even feel there. Okay, what we can do now is take out the the tensioner. We have 2 bolts there in each case.
Somebody tricked a rubber band on it, never take it out.
Beg pardon?
We never take those.
Oh, yeah. I spend more time washing stuff. That's the difference between, you know, I and yeah, I know. I do it for entertainment. That may be a little snugger than that one. Pardon me, Hammer. Not quite. Yeah. This, everything in here is what's known as a schoolroom fit. So, comes out perfectly. I actually torqued, torqued that. So we're okay. We're going to have to break this nut loose, which is going to involve locking it 2 gears at once. Usually, the easiest way is one of the things that the side cover does. Does a few things, but you'll find that. Oh, again, subtle differences. If you look at our front cover, has a plug in it, and Larry's front cover has got switch in it in the same hole here. Okay, this is your lockout for the upshift light in 5th gear. That's what this fella does. Keeps you from saying, go into 6th gear. I keep trying, I know. Okay, you'll also find it if you, and again, not all of you are in a spot where you can see, but if you get looking at the shift fork here on Larry's, there's quite obviously sort of a tapered ramp, which is going to tickle that switch as you go into 5th gear. Whereas the fork on this fellow originally had one, and it looks like they, went in with a hacksaw and sawed the mold off after they decided. You find that some of the newer generation of engine management systems, again, give you an idea of what's going on inside some of these brains. Okay, here the way that we knew that we were in 5th gear was we had a switch that said you are in 5th gear. Okay, what's the newer, the latest, it's more like the 9.5 or the 9,000s, the way that they know that they're in 5th gear is they go over to the part of the microprocessor that's keeping track of engine RPM and say how fast is the engine turning. And then they go over to the input for road speed and say how fast are we going. And they plug it into a simple formula there, and we're doing 65 miles an hour at 2,200 RPM. What gear do you think we're in? Yeah. And if we're in 5th gear and the clutch isn't slipping, then then we're going to say, well, there's no point in telling them to shift up. So you find that one away. If you take this pin out and it's just a light fit there, it's kept from backing out by the cover itself. Then you can go into 2 gears at once.
Be careful because these will pop in.
Yes. You take and go into 2 gears at once, and then we can go and break loose that. I think it's a 32 millimeter.
Oh, yeah.
Which there is nothing bigger.
So this is technically reusable.
So which way we're going with this?
Gears.
Never seen considered lightweight anywhere. I've done probably 100.
Any other manufacturer?
Are we doing this? Walk this again?
Okay, you're putting it into 2 gears. So you take and bring this guy with the pin out, bring him back, and then just pop him forward. So you be in 3rd and 5th simultaneously. And then what we need to do is to get behind and get that bearing off. Usually they used to come off, when they got all gummed in place there, used to come off with the cover.
Want to stay in 3rd?
Your clutch is slipping, bud.
Something's slipping here. Collar on there. A punch.
Running up on the. Yeah, this is perfect.
That is.
Yeah, it's still popping.
Doesn't even know that much.
Oh.
Yeah.
We got that attention to keeping here.
What pin was it you used to put on?
Beg pardon?
What pin was it?
Don't really need it.
No, what I was doing before is we have, and Lord knows where I put it.
Well, yeah, but we have to take that off. We
Yeah.
also have to do the nut.
Oh, there is a, right, this follows.
Can't undo the nut without it being locked.
So,
Oh.
so that's normally, so normally when we're shifting, if I want to go into, say, fifth gear, fifth gear at that
Yeah.
point. But with the interlock, and I can only select one at a time. So if I take that out, then I can manually select, and then any other gear I want. Okay. So that's what I was doing.
Before I start this, is this a good way to get this bearing off?
Good as any. Well, except we're prying against the chain.
Oh,
here.
yeah.
So we don't want to be going against the
No.
chain. Let me try. I don't like pulling on a bearing, but we're going to have a whole lot of choice.
See, those people get in on here.
Oh, we should do it.
The bearing pull through. They usually that snug or?
Well, usually, again, our experience was always they didn't have these on that many years, and all the school stuff always falls off. So if it doesn't, take and run it through the lathe once. So you ever need to do something that a little small in the center. It's coming. I just
Yeah.
need a something to set down the idea there.
Socket?
If need be, I'm looking to see if we've got a million different little.
You got the right tool.
Well, there is no right tool for that. We may have to use the device. Fortunately, there's not much strain on there, so it's not going to do it. No, that won't be a reuse of a two-stroke tool there. Okay.
One of those tags.
That bearing comes out the top.
Yep, that's where it usually comes.
Bigger hammer.
Need something straighten up.
Johnny, you sure that's not a Torrington bearing now?
Everyone knows Mr. Wilcox here.
Does not want to come off there.
No, it's something else. Yeah, we're really, we're back into the end of the shade tree.
You're using an adjustable lens.
Oh, so that would be a fresh bearing, right?
That would be a fresh bearing. Yeah. That would be a fresh bearing. Let's see, we're gonna need something even smaller to, see if you,
Yeah, that should be.
that should be, okay. Yeah. That works a lot easier. Okay. All right.
Now, what would be the reason why that didn't just round up over time?
There isn't even that much, there was not much, it's the way they are, that's it. We're gonna do 2 gears, so we'll take
Right.
and
Within fifth, is that staying third? This one. Yeah. Hopefully.
let's try, yeah, that. Try. Try. Hold it in. Okay, now this, again, we're doing it the flat rater's way there. These nuts are steak nuts. And quite honestly, I've just been a school box, we never stake them. You'll find that we have a soft, relatively speaking, flange here, which was peened down into 3 blind holes in the face of the gear. And if it's not highly, it's not really peened down terribly far, or if they haven't done all 3, you can sometimes do it like I just did inadvertently. And that's probably what most people will do. But you can see how it was set in there. Bear in mind they are like that because you could, depending on what gear you're in, we're again locking in 2 gears, and I've never done it on one of these, but we have had it happen on the Transverse, the 9000 new body style 900 gearboxes. The book for similar operation told you to lock it in 5th and 3rd. And I don't know if you saw, I shifted gears there to get it into reverse because initially there was a lot of spring in there. And depending on how you're flowing through the gearbox there, you can get a real torsion wind-up arrangement there to the point where if you followed the instructions in one of the manuals there on the later box and went into 5th and 3rd, every now and again somebody would actually end up ripping a couple of teeth off some of the gear sets trying to break loose a nut that was torqued down like that. So if you're doing something like this and it isn't coming, or you feel a lot of springing, if it's very springy, try another gear. If it's not coming easily, you can take and usually drill off those. The nut is quite soft. The hub here is quite hard. You're normally not going to hurt the hub. Now, in order to take the chains off here, you find that the upper chain is locked in. It's sitting on a boss, a hub coming off of the gearbox here, and there's a snap ring which is accessible in through the slots on this upper sprocket. So we need to reach in there and expand that snap ring. Okay, that's only one step.
You still need to be in 2 gears now?
No, you can be out there. Okay, let's see here.
You need to finger those on and then. Well, that's good.
You want Billy with flat end on the whole here.
I remember that.
Have you got the snap ring loose? Okay, that guy. Okay, again, schoolroom fit there. That came right off. Okay. Now we can pull apart this. This is, and Ron, where are you at? Oh, there you are. Okay, we can get you to give a discourse on the on this bearing. Here we have a single hand clapping as far as this bearing is concerned. We have a single taper roller bearing supporting a sprocket here, which is a pretty unique way of doing things. But we'll blow it apart later. Again, if you're looking at this fellow here, this is our input sprocket up at the top versus the bottom one. We got what kind of a ratio? This way, we're into an overdrive situation. Again, if you get playing with all the various permutations, you can get to the point where you can have a torque multiplication. You can have almost close to 1-to-1. You can go no overdrive.
See, John, what if I don't have any special socket on your light here?
Two screwdrivers.
Chain wheel.
Hey, Jim. Not all bad. How about yourself? Got your voicemail there. Got a room of 38 people here right now. Yeah, this is a 73 you're looking at? We got how many from the New England Sonnet Club here?
One.
Okay, what kind of shape's it in? Guy says it's in perfect shape. He's buying. We've got a real good technician from upstate New York. You want a what level or a price range, or what do you?
There's a 72 sound.
We'll have an auction.
Never seen a winner.
Huh?
Never seen a winner.
Yeah, there's in upstate New York.
Check on the
I know of one in upstate Vermont.
From upstate New York, so what happens? Is he asking, or is he make an offer type deal?
Sit on the foot. Not lined up.
Okay.
So is that, oh, there it is.
Okay.
Oh, I see the nature of that quest.
Surfing crew here. They will go.
This was-
Get everything. Call him up. I get occasionally somebody wants to give one away, and then you get people that want to.
Yeah.
More. So.
Let's find the elves of her.
No back.
Or the guy wanted your box.
Well, I don't know. I haven't heard of it.
Over lunch, I'll try to get 45 then I'll get you. It was a violation.
Freshly read.
Assuming your front cover matches the rest of the box.
Okay. He likes that. That's fine.
Later than 8 sellers, right?
No. They, are you going to look at this weekend, or are you gonna wait till you? Okay, it's registered driving.
Turbo.
Might be an S-Club.
A lot of backs.
That's a little hard.
I don't know. I'd have to look at that. 0.84.
We've cleaned off the front of both of these now. Okay, we could keep going across the front here. What would like to do at this point, though, is get a baseline on Backlash. So we'll find out where we're setting. This is definitely indication of what's going on inside, and hopefully nothing is going on inside that shouldn't. It's information you need to put it back together again correctly. Okay, so bait setter there. Sorry. What we're interested in now is the free play here. Now the pinion bearings have got so little preload on them here that I can't. Usually you can get in here and this fellow as well. Hold it down. Usually with an and you can pick up the thump going back and forth. And this is in the area, nominally of 17 hundredths of a millimeter, with a tolerance of plus or minus 5 hundredths. And you'll find that the tolerances are inevitably plus or minus 5 because that's the smallest variable between any of our shims. As far as the numbers are concerned, although you usually can get a lot closer, because if you were to go and pick up a pile of 30 hundredth shims and start miking them, you're going to find 28s, 29s, and 30s, and 31s, and so on. So you can fairly well fine tune as you need. So this This one comes easy. Larry's is,
The caps are loose.
Oh.
Broken bolts loose.
okay, yeah, well, we need to definitely bring that back down. The tolerance here, if you go into a classic automotive text, when you get into final drives of anybody's style here, you inevitably get into the pictures where colored up the tooth patterns, and you're seeing the contact area between the teeth, and you have this is good, this is bad type of situation where it used to be used Prussian blue or white lead or a variety of some means of marking one gear running against the other against it, and then by looking at the pattern, being able to see that the pinion is up too far or down too far, or the ring gear is too close or too far away. And way back when, and there's still, I'm sure, people that do it would set it entirely by eye, judging by the contact point between the two gears. We've always gone and done it as a function of. Okay, we got some clearance back here. That was unusual even for a new box here.
Yeah, there was a lot.
We got about 20 or better here. We got a fair bit. This side loose. Okay, both sides are loose. What's happening is he's tightening up these side covers. There are shims between the cover and the case, and the total number of shims, if you combine the thicknesses on both sides, will control how hard, in effect, you're pressing the races against the bearings, and that controls your drag or your preload. Where you put, once you've established the correct amount of force on the bearings, then where you move them side to side is going to control the backlash here. And with all the bolts backed off, you find there are little spring-loaded plungers in the center of the drivers here, which is pushing the ring gear back and forth. So I either had none on. So Larry's carefully torquing it down here,
Right.
and
The dirt by ear.
Yeah.
That's it.
We'll tip up here.
Just till before it snaps, right?
yes, and back off a turn.
Yep.
Okay, what we need to do here is to get in and set up. Yeah. Okay. Now this is a Saab piece, but you can make your own or go to any halfway decent supply shop and find one. The dial indicators here are all the ones that we've always used are hundredths of a millimeter. You can work it out in thousandths if you have to. It's so much easier. All the specs are in hundredths, and these things are not all that expensive. If you are looking, check. I keep you just drawn to you like a. It's amazing. One of the. Anybody familiar with these folks? Or not that I'm shilling for them, but okay. They're in the machine trade. There's a lot of jobbers, but this is the one that's local. I happen to be fond of it because they've got a branch office about a mile and a half away here, and you go in here and, for instance, get into dial indicators. As is typical nowadays, you can get stuff from China, which is dirt cheap, and then you can get American made. They sort things out. They have the economy imports and the good imports and the U.S. They tell you right up front. And if you're buying if you're going to drill 1 inch and an eighth hole in your life, you can buy an $11 drill bit, or you can buy a Chicago Latrobe or whatnot for $79, depending on what you want. The same thing with dial indicators. You can buy them probably for less money than you think you would have to spend.
Yeah. Oh, this is long.
Come down and try to get a decent tangent here, and honestly, just usually end up, if you can get a zero, fine. If not, okay, I guess 20 or more, and we're running at this point 25, which is excessive.
What's the spec?
Spec is depending on what year you're looking at. It's either it used to be we used 15 plus or minus 5. Some later books call 17 plus or minus 5. We have the flex head wrench. We had the 13.
The 1312 here.
Rule of thumb here on these readings is that once a set of gears like this is run 6,000 miles, they've established a definite wear pattern. And you're not supposed to change them. But quite honestly, faced with a set of gears that was running this loose, I definitely would not, one thing to say, okay, I'm at 25. The other thing I have to be careful about here is, again, there's no preload left really on the pinion bearings. I've got to make sure that I'm not shaking the pinion back and forth at the same time and increasing my reading. But I'm still, just even if I'm fairly gentle, I'm getting way too much. So I'm going to end up well, first of all, knowing that I've got excessive amount, I'm going to put it back. But what the changes are going to be, that's something I'll do after on the way back together after I get the ring gear all set, or rather the pinion shaft all set up in the pinion depth, because we at this point still don't know what the pinion depth is. So we just have to kind of make a mental note. This one is way out. Yeah. Now the advantage of having a box which is 11 or 12 years old at this point is, if we change it, what we're worried about is noise, and at this point, our main concern is, does it go down the road? So, there's a little common sense comes in here as well.
What is the thing you're measuring with the dial indicator?
Okay, with the dial indicator, these gear teeth are not. There's actually a small amount of space. The gear teeth are not in actual contact with one another. Okay, so what I'm doing at this point is it's tooth against tooth.
Okay, so you're checking how much it turns between
Right.
sides of the teeth,
Yep.
between faces of the.
Yep. And this is an indicator of, again, it's known as a spiral bevel gear. We have in effect, the pinion teeth are going like this. And these are coming in from the side. If I have an excessive amount of clearance, the more I move the gear over in this direction, the further away from the pinion gear it's going to get, and the more rock I'm going to have. And the difficulty is, let's say that we would like to see the two gears hitting here. Okay, the more clearance I get, the further and further out towards the edge of the ring gear teeth I'm moving. And at that point, you are getting into, the stresses and the impact of the trucks back and forth. You're getting into an unhealthy situation. You don't want them crowded together. You need clearance, but you need to control the clearance. Okay, this guy is, it's about 10 is about the kindest thing you can say for it. This is on the on the tighter end of specifications. And given a choice between the two, this is I'd like a little more than this, but this is a better situation than that. Now sometimes you'll get them quite tight when everything is fresh, and you have sometimes I'll actually throw a wrench on one of the ring gear bolts here to give me a little leverage. You'd never want to do it at something like that because you just end up spinning your pinion around. But probably if I wasn't to lie, I'd have to say this is 900ths on this guy. Now this is not the way the Swedes said it. This has been a part a lot of times in school here.
You can go ahead and just measure one spot.
No, very good. What you need to do, thank you. What you need to do is to go in and 3 points. And you're taking an average. Almost any of these clearances with the exception of the pinion depth. But as far as, say, shim thickness or anything else, you're going in 3 points and take an average. And that's another specification you'll find there is if you have, again, kind of 5 ends up being the magic number. If I had 9, 17, 15, or my 3 readings, at that point, okay, I got 11 here, some variation is typical. Up to about 5 is normal. If I had more than 5, you're looking at, what the book tells you to do is to pop the ring gear off, and at that point you're looking for, in effect, a warp brake rotor type of effect, where you're looking for run out on the face that the ring gear mounts on. Or it could just be that you get a bit of furch on the gear tooth that you were measuring there. So you definitely want to go 3 places to take an average. Now we can check Larry's here, matter of fact.
Well, I can't quite see from over here. What's holding your pinion shaft? Is that still in 2 gears or?
No, at this point it is just this guy's got a lot of preload, and that's what is keeping this one from rotating.
Pinion.
Just the friction on the pinion bearings. Okay. On that one, if I rock it too hard, it'll start moving. So you just have to control how hard you move it. And when you get into say a V4 or 2-stroke, where you're not running on tapered rollers, you're running on straight balls, ball and roller, that'll just spin. And I actually will go in and hold the head of the pinion gear with one hand while I'm rocking the ring gear back on the other.
Is there a reason? Can I just put that in gear?
No, because there's enough slop in the splines, so you'd have more backlash than you could. You could go down. I suppose you could hold reverse gear for the side. That's directly locked on. You could go in with your finger here to do that. But it almost becomes academic because we know it's way out and we know that we're going to reset it anyhow. So,
Which tooth should it be on? I mean, how?
okay, what you want to do is to try to get a
90-degree.
as close to a 90 as you can achieve there. So that, and again, you're probably into fairly subtle. Ooh, yeah. Again, it was 20 where but still quite loose there. Okay, anybody wants to?
I don't suppose it would make that much difference if I torqued it all down to proper spec.
No. You're,
Wouldn't think so.
that's wistful thinking.
So you would put up more things in to make stuff?
No, what you again? There's 2 things at work here. Before we're not done with the shims here. If I wanted to tighten this up, I would have to move the ring gear closer to the pinion. So I would take a shim off of this side and put it over here. But before I start thinking about doing that, one of the steps is we'll strip it down. We'll have the pinion out of there, and we'll put at the very least. Okay, we're going to do driver seals anyhow, so we're going to have the drivers out, and we will put just the ring gear with the shims as they are. Just make life a little easier as they are, and put it in, and then using a torque wrench, find out how much drag you have on the bearings. And it may be that we're going to have to, you might have to add or subtract a shim in order to get the correct preload. And then once you've got the correct preload, the correct drag on the bearings, then after you've got the pinion back in and the pinion depth, then you start to redistribute the shims side to side in order to get the correct backlash. So the shop manual will have you in effect tearing everything down, putting it, putting the shims in a pile somewhere and going back in and starting from scratch. You find that thanks to the fine bearings made by gentleman over here, you can actually pull one of these down, swap bearings, and have it come back just amazingly close. Not that I recommend saying, well, the factory set it right, so I'll just put it back the way it was. But it's usually worth keeping the original shim pack as a starting point, and if you're having a good day, you might just fall right in where you need to be. Okay, at this stage, we need to pop these loose, and what I'll usually do is to take and throw a nut on, leave one bolt in after I get it off, and leave the shims bolted onto the driver here, or wire tie them or something on there, just to keep them in place. You don't need to, add another half hour to the job, setting your shim back again. Okay, so we can go ahead and whoever's running the
It never cleaned like this.
I just brought them upstairs. All right. Now, there's actually, we have a couple different generations of special tools. The Swedes love building special tools. There's a couple of, you have a spot here where you can hook a special adapter for the slide hammer on here. Usually you find that take and just
The other one's not.
so it it's made harder to get.
Well, you're gonna need the air on most of those, I think. Inside.
This has still got some of the remnants of these are. If you're looking at that chart there. Okay, the bolt.
Watch that again.
Moss grease. Oh, Jesus. Okay. You notice that. Yeah. Okay, number 6 there is coated. So all the at first when he started dragging on the air wrench there, I was afraid that we'd going to bring some threads with it, but you can actually see the remains of the coating here. They'll just take and they roll a sealer right around the bolt there. So this is not. It's got. And they won't leak profusely, but they will definitely weep if you don't don't remember to recoat them there.
I got it.
There you go.
Okay. All right, where were the rest of the bolts?
Over next to the drop.
In there.
In there.
No, the next to the drop train.
Okay. Next to who?
The chain.
Chain. Yeah, okay, that's the batch then. All right, so we've got. Okay, so we get turned. Okay, all this time we've been talking about the ring gear. This, of course, is what we're looking at. And if you will take and look at the side of one of these, this guy has 871578, a part number 933, which is the tooth count. 9 on the pinion, 33 on here. And we are going to have somewhere along in here a match number as well. And depending on, sometimes the match number is real easy to spot. You get V4s in the earlier boxes, they actually would grind a smooth spot and take an electric pencil. 6913 or whatever there is as a match number. If you get down looking at the face of his pinion here, we have got +8, okay, and then we have got a 9314, which, okay, right here has been actually stamped in with a metal stamp. So in this case, this is the number which is unique to this particular ring gear, 9314. That you got 5 of them apart on the bench. You got to make sure that the 9314s go together. Okay. Okay, so, +8. Occasionally, different over the years, you'll find a few other codes in there, but the important things are always certainly the fellow with a plus or minus in front of him, and then the matching number on here. I'm not going to do a lot with this, but you'll find that these of course are your spider gears, your differential, and we have a set of 4 gears. 2 large ones, one on either side, which of course are splined to your drivers there, and then 2 smaller ones, pinions here, which are rotating around a hardened steel shaft going down to the center. And again, getting into the generations, changes that have gone on, heavier ring and pinions. If you look at this cross pin here, it is retained with a roll pin driven in through the side of the carrier here. You get back into earlier generations, and the ring gear wasn't as wide. You had enough room so that they actually had a bit of the shaft sticking out of either side and the snap ring on it. Okay, this guy obviously can't. He's pinned. He can't rotate. Some of the earlier ones you could find. Again, if there's any doubt in your mind as far as lubrication, you want to break them down. We have thrust washers. In this case, hardened thrust washers going between the steel and the cast iron of the housing. They're going into a polished cone-shaped seat. You need to check there. You certainly need to check the pin here for signs of wear. Again, sometimes you'll get some Yahoo that just sits and you just envision him burning his way out of a snowbank for about 3 weeks. And this is where one wheel turns up at several hundred miles per hour, and because you're getting a doubling action through the differential here, and so the wear becomes pretty extreme. These are intended to have occasional, differentials in speed, not sit there for prolonged periods.
Different size front tire.
Yeah, different size front tires. Yeah. Seriously, I get a flat and I don't go anywhere. I'll put the Space Saber on the back and move the good one to the front just to avoid that. And if you have wear here, or occasionally, it doesn't happen too often, but you can actually get an egg-shaped hole here in the housing. Okay, we have got Speedo drive gear is pinned on with this wire ring. Diff bearings generally are pretty good. You don't probably do too many, do you?
Never done one.
Never done one.
Will this gear often, break down and cause that
Now it's usually
internal in the
internal
head?
Speedo head cable, that type of thing.
What happens if you're eating through Speedos? I've had 3 in the car.
3 in the car?
Yeah. And they've all
Cable link?
It depends.
Driving too fast.
Yeah, that's it.
Don't laugh. I've
Yeah,
noticed
you're bouncing
accelerating
off.
really hard. The speedo starts jumping wildly, and then it'll take like 5 or 6 minutes to settle down again.
Yeah, that's
And
exactly what it does.
3 speedos and 2 cables. It's scary.
Yeah. Precision machines.
Oh, yeah. Okay. The next, okay, if we get the diff out on this fella? Yeah, we do. Okay. What we need to do, and this is a pending depth of +12, which is pretty doggone unusual. Okay, let's check it and measure both of these before we go any further. And what we're going to do, again, if you want to get an idea of what I'm talking about, pinion preload, I'm sitting here grabbing this guy, this one, and it's virtually no effort at all to swing it back and forth. If you were to reach down and grab a hold of this pinion head, I really have to crank on it in order to get it to move. Worst case situation, of course, is if I could get in here and grab a hold of this pinion and start doing that. That's real unlucky. We're not to that mode. This is certainly within about what you'd expect for the gearbox that's been on the road for a while. You find that you start with what seems like an abnormally high preload to the point where you put it together and say, boy, these bearings are going to self-destruct in no time at all. If you were to take and pull that box down in 1,000 miles and recheck that, you find a dramatic change at that point in the amount of drag on the bearings. All right, we need to get in with the pinion depth gauges, which there's a couple floating about. Take. All right, need to check and make sure that the gauge block here is in decent shape. Need to check here, 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 and certainly in here. If you get somebody that's been using and abusing, if you have, if you catch something with your fingernail here, you've got to get in and dress it. And what I'd usually use for something like this would just be you have to be careful, but just even a single-edged razor blade held at right angles and carefully, lightly scraped across there. Because the other gift to creation is this stuff, Scotch Brite. You get the greens and the browns and everything else, and this will, clean a surface up so you can see, see its condition without changing dimensions. You can use this a fair bit. Something else is worth, so Scotch Brite, something else that I end up using a fair bit is these little diamond laps that look like they're on a toothbrush handle, a little short diamond faced abrasive. Or if you have access to a machinist's fine oil stones there, you'll find there's a lot of times where you go in and touch up surfaces and bring them back. Okay, so now enough about nicks. What I need to do here is we're going to go down and I'm going to drop the gauge in, and you find the pinion is not dead center; it's offset somewhat. And you have a choice of where do you put the gauge. Put the face of the gauge towards the nut here so that you can sit on this side where you're lower and look at it. But before I can use it, I need to go in and set. And you find that you got a wide range of travel on here. Pretty much all you really need to do is to, again, make sure that as you're setting this and zeroing it, you know where the small gauge is, which gives you the total number of complete revolutions the dial has made. And then, of course, the large needle is zeroed out, gives you your hundredths of a millimeter. If you don't pay attention to what happens with a small needle, again, you could conceivably end up one full revolution out, which would be disastrous, because we're talking about a change of 10 hundredths of a millimeter being the difference between noisy set and a quiet set, or a strong set and a weak set. And if you get off by a factor of 10 over that, then you're in real trouble. Okay, so we're going to take and zero it. Okay, and then we're going to go in, and you have to be careful as you go through not to knock the dial indicator. Usually I'll take and rotate the pinion so that I got a spot, a face that doesn't have the etching on it. Okay, come in, looking for a flat here, and I'm just going to sit, kind of lightly hold it down, and we're going to rotate until it comes up, stops, and changes direction. It's like finding TDC on a two-stroke.
John, can you rotate it 180 degrees? Bring it this way for the camera.
All right. So we've come in, set down, and we're going to take and pardon?
Yeah, a little bit to your left.
Okay.
That's great.
Can you actually? How close can you get there, Seth?
I get pretty close.
Okay. So we're coming until the needle stops, changes direction, and at this point,
For the peak.
we're looking for the peak in effect. And catch my bald spot there, Seth.
This is like training a transmitter.
Yeah.
Okay, we are 9 graduations counterclockwise from the 0 point here. Now this is marked plus 10, plus 8. Okay, this one is reading plus 9. So you're, in terms of luck of the draw here, you've, there's nothing, so far that you'd have to say, boy, we're in pretty decent shape. All right, again, if you go through those pages, you don't have to do it now, but if you go through the pages in the book, do we have another one of those kicking around? I set up a couple of the.
There's one right here.
Okay. Okay. Now, we're set here. This is an old German one that I liberated from the rebuild center at Waterfront Street. It's a beauty because you can zero both, and it has the movable points here, so you can pick up your, preset your limits. Okay, we are 0, on both of these needles here. Now, again, this gauge block, right now I'm reading 0 deviation from my baseline setting of 60 millimeters, the distance from here to here. Okay, now if I have a pinion which is going to be happy moving 0.08 of a millimeter away, I can simulate that by moving the gauge block down away or lifting up the tool, and watch the needle as I lift. The needle is going counterclockwise. Okay, now the way the gauge is set, you're going, some of these are marked plus and minus, and the temptation is to say, well, clockwise has got to be plus and counterclockwise has got to be minus. Here, it's really easy to put it straight in your mind. You just visualize what has to happen. If it's plus, we're going to add, we're going to move it away, and it's going to go counterclockwise. If I have one that's marked negative, which is, again, entirely conceivable, I'm going to move the face of the pinion up, and that's equivalent to lifting here, so you're going to see it go clockwise. Okay, so this one is about as perfect as it's going to get. What do you have for reading over here?
Pretty close, 12.
12. Okay. Yeah, that's fairly, it's getting on the edge. I think I've seen them as far as 17. I'm not sure if we've seen one beyond that. Usually, for years and years and years, they were normally in the single digits. And you get 3s, 4, 5, 6s, 7s, that sort of thing. Okay.
And that's their judgment of how loud it is, basically.
Yeah. Again, it's my understanding. I've just like they balance the turbos by actually putting them in a sound cabinet and running up with compressed air and setting a microphone in there. They're presumably doing the same thing here on these. If they are literally running one against another. And when in doubt, if I get a cockeyed reading, I'll go back in and check my 0, once or twice. It's conceivable that A, I goofed, or B, I knocked something as I went together there. Okay, now with the gearbox on end like this, if you look in here, you'll see that we have got right at this point, there's a total of 5 bolts that you can see. 4 are holding the pinion housing in place, and 1 is holding a lock plate for the shafts which support the cluster gear and your reverse idler. And before we can go a whole lot further on here, we're going to have to get the front housing off. So we'll go in and this is as good a point as any to go in and remove the bolt which is holding that lock plate in. And with the plate out, then we can put it level again and start breaking down the nose, pulling shafts. At this point, the gears, cluster, gears on the pinion shaft are in mesh with each other. They're also locking each other in place. Before we can get the gearbox apart, we have to drop the cluster gear down in the bottom of the case so the gears can slide by each other. We also need to get the reverse idler out of the way. So if we go down in there with that's a 13.
You need a longer extension for this.
Yeah.
I guess.
It's just a slow interval. You see come up and you stop.
Yeah, so tuning a transmitter, you can go free peak.
Yeah.
Dead on. All right, so we can take it and actually for this, that's a pretty critical. Right there, who's got the ratchets? They're all good. For the back room, I guess. Is there a crates ratchet behind you there? They do a little more Loctite than it's absolutely called for, but this is definitely one you don't want coming loose.
Which one?
The one that's holding that lock. Yeah.
Okay.
So I'll usually use some blue, medium strength Loctite in here. Something else that again isn't in the book, but I like to do is to check this plate. Now this is a fairly crudely, manufactured piece. It's a, stamp with a cookie cutter. What I'm looking for, though, is an excessive amount of rock here. I've seen them to the point where they actually will have a hairline fracture in the center. I have seen these broken. The purpose of this is we have notches cutting the ends of the two shafts, and this is sliding into the notch, and that's what holds them back and forth. And normally there isn't a lot of thrust on here, but on occasion there can be, or you get some Yahoo that doesn't have the shaft seated all the way, so he gets them within a quarter of an inch and then use the bolts to drive the shafts in. And of course, you're putting a lot of strain on this plate at that point. So I would just like to always double check those. Okay, yeah, you don't need anything real exact, but they'll all have a little rock to them, but it's got to be fairly close. Okay, something that has happened at this point, and it's not the end of the world, the reverse idler shaft on this guy dropped forward.
Will that fall out?
I'm just going to do it level at this point. What we need to do is take and okay, we have to break down the gearbox, and that's going to involve, among other things, separating what's in the front section here. We have in the front, we've got the input shaft where our lower sprocket was. That's in a plate held in with 3 bolts, and you'll find that we have got a couple of oil collecting devices on there. Okay, that's going to come out. From the side here, you'll find that we have got the 5th gear shift fork, which at this point is free to float because we took the pin out. We have got, first and foremost, though, before we can move this out, if you were to look in here and say, well, I want to pull this, slide it on out in this direction, you'd find it go a little ways, and they'll end up hitting against the end of the cluster gear here. So we need to get the end of the cluster gear out. And you'll find that the way that all this is held together here, it's a 2-piece cluster gear. And if you look right in here, we have a snap ring whose function is to hold a collar splined on the ID, and that collar is serving to bridge the 2 halves of the cluster gear, or the 2 sections of the cluster gear. Also, if you look at that collar when it comes out, you'll find that one end is perfectly flush and the other one has got a step in it. The step is designed to sit over the snap ring there. So we need a pair of snap ring pliers that will expand. Right angle tip that will expand.
John,
Is it plate?
there's a guy outside with food. He wants to know where
Oh.
you want him to.
He wants money? Oh.
And to control the drag here, what we're looking for is absolutely dead perfect, no end float and no preload. If you have end float, you're going to destroy the bearings. If you have preload, this is part of what you're driving, and this is one of the things the synchros have got to overcome. Part of the rotating mass when you put your foot into the clutch. You've got the mass of the chains. You've got this. Part of the reason why the synchros have always been such an issue is you got all this stuff that doesn't exist on just about any other gearbox. All of this has to be brought to the same speed as the final drive here when you're shifting gears. So you have to be very, very careful to avoid having either drag or play. Now, to control this, you'll find that if I blow this apart, and a matter of going in the press, supporting it, pressing off, that rather than just have the bearings sitting there on the shaft, we have a combination of spacers and shims between the two here, and it's a matter of the process for putting it together is they tell you, okay, we're going to start with new bearings, and we're going to intentionally over shim it so that we are holding the 2 bearings far apart, and of course that's going to give us end play. We're going to simulate the torque that's on this nut here by putting it in the press and running it down to 3 tons. Now, you can get for another, for $1,000 there, you can get a nice Enerpac press for that, and another couple $100, you get a nice big gauge that goes on the top that translates PSI into tons. 3 tons is a pull and a squeak. That's you just get into, you get a feel for it, and again, intentional excessive shim pack. Again, if you follow in the book, you go in and you preload it, you lock the bearings down, and then with a dial indicator, you see what the clearance is. Oh, it's 25. I want to take out 2,500s worth of shims. I want to get this down to the point where it is no clearance, but no drag. You don't want to take out 30, because then you go on the other side where you're pushing the bearings into the race. Again, all this probably in the real world gets fairly rudimentary, but you do want to have it just as this one is here.
They don't feel
So would
very
you do anything to that at all? Change the bearing or?
This thing looks pretty darn good so far. I'd wash it out and that's put it back together. Yeah.
Second owner of the car. One of those, by the very drill.
Well, you got glass harder than fixing this stuff.
Okay.
Actually,
All right, let's get there.
4 or 5 blue boxes.
And then
You have to rebuild them.
Yeah.
He said.
it's where you. Okay, that's one direction, and we try it the right direction and see what happens.
Preload better now?
Yeah. No, I didn't get.
Where's that?
It takes quite a while to get the.
Well, that's shops.
Yeah.
Or lighthouse.
Looks like
When I put a built one 2-stroke, I went there to build that. It was great.
Is that the same torque wrench you used to tighten it up?
Yeah. It is, well, actually, that is
Real
the
good.
torque wrench you used in the beginning.
the
And
3-ton press.
yeah, and you find that one of the drawbacks is that if you're 150 pounds, you go get the piece of pipe, and even I'm at whatever there, and you can bounce on it initially. There's there is a definite initial effort to getting the sleeve to collapse. So what I mentioned in the book there on these is to go and you'll find with the the bearing is still on the shaft here, but when the crush sleeve is new, you can take the housing and in an exaggerated sense you can do that. So what I'll do is set it up in the press and very, very gently come down until I've taken out virtually all the end float. And at that point you've kind of eased the way, and then it becomes a lot easier to collapse the rest of the way.
Okay, this is an intentional collapse that you're talking about.
Yes, yes. Yeah, and again, if you're not that comfortable with or familiar with the concept of a crush sleeve here, we need to, not every application, but most applications, pretty critical ones with this, you need to carefully control just how much tension there is between the bearing and the seat. And in that front assembly there, I mentioned we were doing it with spacers and shims, where you're going in and changing one thickness for another. Here we're starting with just a piece of tubing which is already started into it's been deformed, so it's going to collapse in a controlled way, and you're going to go in here and you're going to slowly collapse it all the time, checking the preload here until you're correct, so you have the right amount of drag. And one of the
You're collapsing it by tightening the nut?
yes, well I start with collapsing it without even the nut, just by collapsing it in the press. And I'm probably about the threads here, but this thing is got enough the grip there, so it wants to. Okay, time to get violent. This will. We have. So we want to just kind of gently
We're currently smacking up with this.
Other thing I could do. What I was holding this with, by the way, was a
Special tool.
special tool. Yeah. Now, in absolute pinch, you get a couple old hubs, same splines as the hubs, and you can take and cut some steps into those. I'd use two of them so that you could, spread it a bit, because you do need a fair bit of this. You can, in a pinch, cobble up some of your own. Okay. That's all. Now, what I'm going to do is I need to clear this off of the housing. And what I need to do is to push just this bearing off. We have a special tool for pushing this bearing off, but the last thing you want to do is try to push both of them together, because you're going to guarantee you're going to break something. This one is should not be all that hard to get off. So we'll go and drop the press down.
Yeah, there's rough stuff. You'll hate to swing it out.
What do you do with that? You don't have to take it down and then.
We have got.
Or it's possible that somebody changed.
Bearings
Right.
and of course races.
Yeah.
Okay, we have got a classic here. Where's Ron?
Small.
Small, yes, as opposed to Brunelling. You get
What are the
we got
differences?
metal missing on there. There's a couple of classic failures. These you'll normally spall, which looks like somebody's just gone and dug the metal, raked the metal out as though it was flakes of metal missing. You get some other classics with like you get a part of V4 gearbox. If you have a whine in second gear, you usually find that it's what they call Brunelling. It looks almost like somebody took a pencil and made tiny little parallel marks in the inside of fourth gear. And be very, right. If you haven't, most of you know Ron. He's works Torrington Bearing there, so just pick on him for any bearing related related issue. Okay, here's our crush sleeve. Okay, and again, it's just a piece of tubing that they've shaped in a very definite way so that it is set to. It's obviously got to fold up in the middle here.
That's a one-time only.
That is one time only, and that's
I'm cheap and that's still one.
yeah, that's one time only, and that's the oops, you went too far.
Yeah.
You throw it away, and I mean this isn't one per gearbox; it's one per tightening. Is what that is. Now we're left now with removing this bearing from the pinion shaft, and the challenge here is that there's really nothing to get a hold of as far as the bearing is concerned. Technically, again, we're scrapping the bearing out, so there's actually a variety of ways. Whatever you do, you have to be careful. The official technique is we have a support tool with a like a gear segment that is going to mesh with this one, and the teeth on that gear segment, as this goes down, are going to push the bearing off the shaft. Okay. If you have access to one of those, even if those Saab special tool, you have to be real careful, because what's happening is this guy is going down. It not only is going down, but it needs to do that. And if everything's set up tight in the press here, it wants to rotate, but it can't. And typically, as you're getting the bearing back 3/8 of an inch or so, and the tool is starting to clear the ends of the pinion teeth here, if you look at one of these and the ends of a lot of the teeth are broken off on the side facing the bearing, you know that somebody's been into it before and wasn't all that careful about it. A couple of different. Let me go get a variety of special tools there. Go over and match this. We've got a whole variety of these. This is the official tool here.
What's the unofficial?
Right. If I get real desperate, you're going to scrap the bearing anyhow. So what you could do is to take a pair of dikes, and carefully the cage here is pretty soft, and that leaves you with a a bit of a lip on the bearing. If you had a real good bearing separator, you might be able to grab it. Another thing that, is not not that one. These are what happens when we give give a German some leeway here. These are very nice. This is out of the VF kit. Nobody ever uses them for the the original intention, but these are collet type bearing pullers. And if you look at this as it comes around, I grabbed the wrong size naturally, but this will sit down over a bearing. We have tapered cone-shaped sections separated by springs, and as you tighten down here, it'll grip the bearing, grip the roller, and then as you pull, the roller transfers the thrust into that little shoulder I was talking about, and it'll pull the bearing off. It's a slick tool, but it costs more than the average used 900 at this point. So, okay. Now this is going to come down through. This is designed actually to be bolted on here. This is a carryover from the Borg Warner Type 35 days, and we just kept updating it with tools. You don't really need to bolt it down. These were tapped so that you could bolt down either one of the Type 35, Type 37 pinion housings. You had to lock one of those in this fixture before you take the nut off that holds that all that. But here we're just going to use this as a press tool. Okay. Another option, keep trying these till I find one that fits, is to. Nice thing about this collet, if you had one, is that it's grabbing the bearing and you're pulling the bearing off rather than pushing past the gear, so it's a lot less likely to to destroy anything. If you're using this tool, what you need to do, or what I always do, is I lube it up, and then I will press just a tad, loosen up, center it, press, loosen, press, center. Just keep rattling it around because it is taking like a quarter of a turn as it goes through, and if you're holding it back, it will chip teeth. What do you guys use for pulling bearings? What's the efficiency?
We try not to get ourselves in a situation. Proper design.
Right.
I probably never
Permanent life bearing.
not certain, so I can. This point, probably.
Like a chicken place, the drill, you're not so out, right? And then just pull up the edge and pour I never get the grade level. If they did, they were just.
I hear you say you're in Westchester.
Okay, so we've taken this off and without the danger of potentially chipping teeth here.
For parts and stuff like that, we go to Arrowhead.
And there we have the second pinion bearing. So now you would. I figure that for every hour I spend tearing down, I'm probably going to spend another hour cleaning. That's my own personal. At this point, before I put this thing together, I would march over to the wash tank and spend. Everything should be scrubbed down. Just
Go in there.
to a certain degree. If you're flat rating it, you can clean all of the surfaces, but I really like to get the whole thing, scrubbed up to fairly well. And certainly need to be aware of the fact that there are lots of little pockets with all these oil feed holes. Things like the oil collecting cups behind the covers, on the covers. Any place where we're collecting and feeding oil, you can get some really hard packed, little brass bits and pieces. You don't want that stuff busting loose and going through afterwards. So spend some time scrubbing there. About the same as a crankshaft there. You take and at the very least flush it. It wouldn't hurt to have a bore brush of some sort going down through there to clean that up. Because we are, again, from a loop standpoint, the oil that we've collected up front, about there, is coming there and there and there, and there. So we're drilled clean back to this point. So you have a long cavity where you potentially have perch collected. You don't want to let that be. Now, what I'm going to do here is just put this back together with Larry's bearings. And let me see if I have a crush sleeve. Be careful about is whatever you're using, it needs to contact just the race here. That's the thing. You don't just get any piece of pipe or any block, because typically, you may very well, you don't want to ding the cage here. You certainly don't want to, if you're getting into putting in say a whole ball bearing, you don't want to have all kinds of force on, the tension is on the inner race, and you've got a 2-inch socket and you're pounding on the outer race, because every time you nail it with a hammer, of course your force is going through two very hard surfaces and a hard ball in the middle there, and you've destroyed the bearing before it ever turns. My own personal preference on these guys is to take and I'll usually flip my drop light open, the cage on the drop light open at this point, and just lay the bearing down on the bulb, right on the bulb, and that do the same thing with fourth gear driven on the V4, the 2-stroke gearbox. It'll go down. You have to be fairly quick, because they'll get down about halfway and cool off, but even so, it every bit helps. And because these will get to creaking and groaning pretty good. And I always worry about shading and perhaps catching a little bit of metal between the edge of the bearing and the gear head here. So if I was doing this for real, again, I would go in and heat the bearing.
Would you recommend putting anti-seize on the shaft? Or do you want a dry fit?
Probably wouldn't hurt here. I'm not sure. There's nothing against it here, because it's not going to, again, something like, interference fit gears, you wouldn't do it. But, and again, I ask you, is that something that you guys would specify in your?
Usually it's a design fit to it. We don't have things too much like that. One, we don't make a tapered roller bearing. We're dealing in ball bearing.
Okay.
We usually have a loose housing
Mhm.
and a tight shaft, which
Okay.
is only a few tenths.
Right. Now you,
And what we will do is we'll warm a bearing or chill a shaft or cold.
and you can get, if you go through like a Granger catalog or that MSC there, you can get official bearing heaters, which are an inductive type of device there. But I've always found that a light bulb doesn't hurt anything, and it's about right. I will chill some stuff, but it can sweat too, so I usually heat, but that's a matter of preference. Okay, let me go ahead and we will. Let's try this guy. Yes.
Yes.
Whole winter night, you go out and look, and it goes crash, you'll take a look.
No, that's color.
Sleeve that I was using.
So.
Well, there.
Oh, not. Not quite enough. Well, there. Now this has not been clean as I normally would. Okay, so we would take and we're gonna have to, lube this as we go back together. And again, whatever you're going to end up running as a gear oil, or even back off from that a little bit. You get into some synthetics, particularly some additives, can be really tricky when you're doing preloads. You get the snake oil, gear lube additives, where the guy, name your brand there, has got a bearing and a fixture that'll tighten up on a shaft, and he keeps, puts motor oil on there, and it comes to a screeching halt, and he puts one drop of, whatever it is on there, and it spins free forever. Don't recommend any of that, but just, if you're tempted to use some of these things as a prelude product here, I quite a while ago I just had a can of whatever it was and put it on there, and found it was unique, because when the bearing sat for a little while and whatever it was had gotten pushed out and you had metal to metal contact, it was hell to break it loose. But once you got it moving, the preload was nil. It made it very, very hard to gauge the prelude. So probably I would use motor oil on here, and you're not going to have enough of it in there to interfere if you end up using something else as a product. Okay, is the old sleeve, the one that was we took off of there, that was making the rounds right there. Okay. So and you believe me, you want to keep these things. If you have a bunch of them around there, the last thing you ever want to do is take and put your old you reach over and you got 3 new sleeves on the bench, and you pick up the one you took out. That gets real irritating. Just want to give you an idea of how much collapse we have. Okay, this one is just a whisker under 20 millimeters, 1995. 20. Okay. This is the one that's collapsed, and we're looking at 18.8. So we have over a millimeter worth of collapse here, and again, if you compare, if there's any doubt in your mind, if you can compare them, even just side by each here on the table, there is a difference. So we would drop that down, take our pinion housing, and we get a drop of oil on here. So there, crushable sleeve, and
So when you're putting races in that housing, we use a light bulb trick in the housing. Press the races.
yeah, you again wouldn't hurt there either. We're gonna unfortunately just run out as we get there, so we can take and technically here, all they will probably have you do in the book is to get started until you get the nut on there. You sure as heck want to be, of course, with that spacer in there. I'm not going to get down to the point where I'm banging that bearing against the wrist, but at the box there, you want to avoid doing that. Okay, right now, I've got all kinds of
Excessive play.
there. That is no preload.
You still have to. I'm just doing this.
You'll reach a point right about here where the bearing is as far as it's going to go without contacting without starting to clash the snoots. At this point, you start to beep and groan. And this period that I'm in right here is where you end up bouncing up and down on that wrench trying to get the okay. I've got to the point where there's no preload. We're not excessively tight either.
Does this not get red Loctite?
Oh yeah, it's not specified, but I don't put anything like this together without red Loctite. Okay, and reuse the same old,
Even with the detents in it.
even with the detents. Oh, we've got a proud history of shaft nuts. Again, not to go back to the V4, but that was kind of the classic where you lose. Somebody was talking earlier about speedometers. You lose the speedometer is the early warning system on a two-stroke or a V4 for pinion nut tightness.
It's 25 miles an hour. I went down here today. When I lifted off, I got 25 miles an hour.
Did you? Yeah. Okay. We've got a stack up there. You got a shaft with 2 gears on it, and sandwiched between the 2 gears is a assortment of spacers with your speedometer drive gear. The drive gear is not keyed to the pinion shaft. It's just there by friction, and everything is locked down by the big nut on the behind the rear bearing, which also controls your pinion depth. And that has got, over the years, we've gone from a sheet metal plate to a pretty elegant setup with a 3-stake shouldered nut like we're using here. And still, you just at some point your speedometer starts acting flaky, and you find out you take out the speedometer drive and reach your finger down there, and you can spin the the drive gear on the pinion shaft, and that's nuts loose again. So I always I mechanically lock them and I Loctite them. Just no discussion. Let's see. Actually, look at the box. This one's tight enough. Let me see if they're related.
That's what you said, is the same as the hub?
Oh yeah, that's so in a pinch there.
Well, we've got a lull here, I'll mention, and I know this is going to put a frown on John's face, but I've got a box full of all moving parts from inside of the 85 5-speed up the car, if anybody wants them, come have them. Crack the transmission case, but the parts for all with transmission.
Such a deal. Okay, now there are 2 techniques.
How do you crack it? Went over a frost heave up in Maine. We'll go into that later.
How often do you do that in Maine?
Once in a lifetime, believe me. You watch it after that.
So you struggle.
Hasn't even started.
Workbench too.
Oh yeah, no, you need a good work reach. Okay,
Transmission was there. I got to stand.
now we're coming down to gets to the point where it is. I'm just starting to get some preload here, and again, there are 2 techniques on this. The one that I favor is to take, and first of all, I would take, this is much too light here. This is barely, in effect, barely touching at this point. What I prefer to do is to take and thread the nut back on the end, take your 24mm socket, step it on down to quarter drive, and use, probably the ideal thing would be an old beam type torque wrench. It's the flexible shaft style. What I usually use is a quarter drive snap-on dial type. What you can't use, of course, is a click wrench, because you don't have a running count there. But before I'll do either of these, and again, I'd come down a bit more than this. Before I would do either of these, or certainly before I finalize it, is, and these are,
I can hear it.
oh yeah, these are not. This isn't even worth the effort here. But I'll go get the string. What in several cases, for instance, when we're setting the preload or the no preload on this, you'll find that part of the technique involves, before you take a measurement, they have you pressing down and turning 20 times, and pressing up and turning 20 times. Characteristic of the taper rollers here is you'd say, boy, that is a perfect funnel. That's going to drop down in and just line itself up perfectly. What'll happen is, what I always do at home, is to get to the point where I think I'm fairly close, drop some more oil on it, carry it over, and chuck this up in the lathe. Put the lathe on slow and grab this, and just spin the doggone thing. What you're doing is, and it might, first time through, it might sound like, oh, you're just knocking the speedy dry off the bearings. But what really happens as you rotate them like that is they will actually go from being a little cattywampus to finding, when they're in motion, they will find their track. They'll center themselves. We've got this process refined on the 9000 gearboxes to the point where several steps during the operation, we have a tool which I'm sure would work on this. It's nothing more than a piece of Swedish garden hose with a coupling that'll go in a 1/2-inch drive drill. So you put the box together, and you put a dial indicator on the opposite end of the shaft to measure end float, and you sit there with the drill slowly up, down, up, down, up, down. And time after time, if you do that, and this is typically still when we have some play to measure, if you move it and get a final reading of 20 hundredths of a millimeter end play and shut it off and move the shaft once, you'll get 20 hundredths once, and the next time you do it, you'll probably be down to about 10. Which is the difference between those bearings being perfectly seated and going slightly skewed in the race there. So I like to, again, just spin it up for a little bit. You don't have to burn the thing up or anything, but just spin it around for a while in the lathe and try it. And typically you'll find, boy, it just went down a bunch. It's a lot lighter than I thought it was going to be. And then I'll tighten it up again until I finally get it where I want it. Okay, let me do the Swedish fish scale routine here, because that's the spec is 4.7 to 7 kilograms, and you can work that over into pounds if you want. The only limitation to the one that they always supplied is this: the high end of this is 5, and if you're going to set a preload, you want it on the higher end. At first it spooks because it just feels too doggone tight, but they go down fairly quickly. So if I'm using this, one of the reasons I don't use it, I have to end up being, well, not quite that far, but, at the end of the scale. These do have a useful function, though. You find that these are great dirt detectors. Okay, so the technique here was to get in, and what you find when there's problems with the bearing is it does, maybe just he gets very exaggerated here. Every time we hit that that spalling, it just and it didn't feel, you could hear it, but it didn't feel that bad. But even with good bearings, if you've been a little bit careless, you're not quite as sterile as you should have been, this thing will sit there and it'll do one of these numbers. It's all over the map. So it's a real good indicator as far as dirt goes. Again, we know that this, there's no point in going too much further here. But if somebody wants to, you want to swing on that, just get a feel. If you, feel free, we can't do it any harm. We'll gladly sacrifice a clutch sleeve there, but that you really have to lay into that fellow.
I've talked to a couple of rebuilders that just do it by feel. 20 or 30 boxes in, they thought they had it programmed into their wrist there.
Yeah,
So we can check.
there are people that intuitively do that. There are people that are just lucky. And then you also find out just how forgiving machinery can be. But it's that's like, never use a torque wrench, that type of thing. It just isn't. You got that much money and effort involved. It's it's silly not to do it. Okay. So that in order for that to be functional. Okay, another area that I think we really only have 6 minutes worth, but where are the side covers? Oh, right, staring at them right in the face here. Okay, what we would next do during this teardown is I'd have the main case, of course, completely been in and out of the wash tank, stripped. Or completely washed, every blessed bolt checked and helicoiled if need be. plan on, certainly, do that well in advance, because then you have to go back in and wash the whole thing all over again. Clean it up well. And then, unless you're in a real hurry, what you're going to do is to go in with the snap ring pliers. These inner drivers are held in place with a snap ring, and this is something that's changed over the years. Again, up through '74, all you did was to get a tire iron in behind the driver here and pop out the cane, and sometimes you didn't even have to do that. A few of them were self-liberating, but okay, on this, what you would have to do is go into the snap ring pliers, pop the snap ring, and there's a ball bearing in here which is actually supporting. And then, of course, the axle seal beyond that you need to remove. Okay, at this point, what I would do is pop these out because I'm going to be replacing the seals anyhow. Wash them up, clean them. In all probability, we're going to be swapping them from side to side because again we have this definite wear pattern, and by swapping them side to side, you'll reverse the wear pattern. Just the one kind of warning on that is it doesn't make any sense logically, but on an automatic, we found that when you swap them side to side, you'll get into a severe vibration in gear with the brake on. You're sitting there in drive, and you'd swear that one of the balance weights fell off the torque converter. It's grim, and it ends up being that we found out again through the rebuild process, where you get a gearbox where the rebuilder has swapped the drivers to give you a clean driving surface, and the wear is on the side that shouldn't matter, and the things will sit there and shudder and shake.
They vibrate before you switch them too. The point is it just doesn't work switching one on. They vibrate before you switch them and after an automatic. The point is you don't gain anything. That same transmission was vibrating before they can switch. It's not just it just doesn't work.
The thing is, it looks logical. Oh, I can fix that shape.
Works great.
Okay, so we're going to take these off. Then we will remove. There is an O-ring. Again, talking about sealing this, keeping these from leaking. In addition to having to have thread sealant on all of these bolts when we finally go together, we're going to take the O-ring off. You need a fresh O-ring on here because they've taken a real set. And take the O-rings off. Set the ring gear without the pinion, just the ring gear in place in the gearbox, and might as well just keep the original shim pack here. Take and lube up the bearings. Again, they hold up real well, but at least clean and oil them, and bolt the side covers on. Now, without the side covers being there, you can grab another Saab special tool and this one you could make extremely easily. Okay, what this does is we'll go in to the side here. It's got a fork to it, which grabs the crock shaft here. And so we've got the shims, which are controlling preload, and we got everything set in and torqued up. And we'll take and throw, again, inch-pound torque wrench on here. The alternative to that, the original technique is you wind your string around here, and again use the Swedish fish scale. But the torque wrench works ever so much nicer, and again you get your rolling torque. And in the book we'll refer to new bearings and used bearings. Again, there's a seating process here. I don't think I'd shoot myself if I did put in a used pinion bearing torque, because that's you need to be lobotomized at that point. But or you'd already been, one of the two. But at any rate, these, you can very well, if they check out well, you're looking for the spalling and everything else, you go with the old bearing spec, which is at a much lower level than new. You don't want to take and use the same tight standards for new bearings as you would on used. So you check them, and you find what your preload is. And if necessary, it's just trial and error there. Usually you're going to be so doggone close that you're going to be working with your smallest shims, 10th hundred, the 10th of 100, 10 hundredths, rather, excuse me. And again, put them back as close as you can to the way you had them as far as orientation left to right. And then once you know that you have the correct shim pack, you don't mess with that. Later on, all you'll be doing is moving shims from side to side, but you never say, oh, I need to move the gear that direction, so I'll take and throw one of these guys away. You don't want to do that. All you're going to do is redistribute from side to side. So you would get this set, then you can go ahead and I'd probably, just for ease of handling, leave the drivers and the O-ring off until I'd gone through my final backlash setting, because it's a lot easier to get all that on and off without the friction of the O-ring. And then I begin to go back together, stacking everything up on the pinion shaft.
Right.
And at that point, as the English manuals say, it's reassemble in reverse order. So,
Stack shim?
Yeah.
Stack
oh,
shim?
thank you. Yes. Let's bring that over, and the shims, and they don't line up with anything. That goes way back to the 1.7 liter 99 gearbox, where everything was so much smaller that the center lines between the shafts were much closer, and these notches were to clear those round shafts that we pulled out. So that is a supply hole. We've got, as far as orientation goes, it's pretty hard to go wrong anyhow, but we need there's actually a collector cup built in this housing here that needs to go to the top of the trolley. So we need to put this on. Now this is one of these, we have to get the pinion depth. Well, we had to do the preload before we could do the pinion depth. Then we do the pinion depth, and once we've got the pinion depth under control, then we can go in and do our stack height.